Hello and welcome to Geography Rocks. This is resource management lesson number 4, and today we're going to be looking at a case study, and it is called the Indus Basin Irrigation System, or the IBIS or IBIS scheme. It's available in your revision guides and it's available for you to look at and learn from in Caboodle. Last session in Resource Management 3, we started to consider how food production can be improved in certain countries to help stop malnutrition, etc. So this is one way that food production can be improved. So this case study is about using science and technology to improve food technology. So let's start off by having a little look at where the Indus Basin is and what's going on there. So we're going to have a little look at the map and then consider the historical context of the region. If you take a look at the map, you can see the Indus River in the orange section, which is in Pakistan, and you can see that it starts in the north and it travels in a generally southern direction down to the Arabian Sea. The first question that I've put up on the slide is, describe the route and the location of the Indus River. This is likely to be a 3-mark question. The examiner would be looking for you to use compass points and direction, so north, south, east or west. The examiner would also be looking for you to name the regions and the countries around, etc. Try to use both maps so we can see part of a world map, so we can see that it is located in Asia, and then try to be specific about the actual route of the Indus River. Do not get caught up in talking about the fact the Indus River travels northwesterly, then it travels westerly, then southerly, then southwesterly. Just give an overall trend of the direction of flow. So my response says this: the source of the Indus River is high up in the Tibetan Plateau. It travels north to south through the length of Pakistan to the Arabian Sea. The Indus drainage basin includes parts of India, China and Afghanistan. It might be worth pausing here, putting a title, the Indus Basin Irrigation System, and then just writing down the route of flow of that river. And if you can print out a photograph of the map, absolutely brilliant, stick it with your notes. So let's take a look at the history of the IBIS system. So the Indus River is important to both India and Pakistan. It provides valuable water supply to both of those countries. In the 1960s, there was a water treaty, and as a result of that, India had control of the eastern rivers, and Pakistan had control of the Indus River and all the western tributaries. So there's a little bit of context, a little bit of history. The IBIS began as a series of canals which were used for irrigation, and over time that system got bigger, and it now includes 3 large dams and 100 smaller dams. On one of the next slides you'll see a picture of the dam, and you'll see a picture of the reservoir behind the dam, and it gives you some idea of scale, because sometimes in our minds we picture a dam and a small reservoir, whereas this is a much larger scale. There are 12 link canals which allow the water to be transferred between rivers, and by having these canals and dams we're able to move water from one part to another, and therefore more area can be farmed. So this is what it looks like as a little map. Feel free to pause and just take a look at this diagram, because it's an unfamiliar diagram. We've never seen anything like it before. Down the bottom you can see the Arabian Sea, and then you can see the Indus River travelling northerly up the diagram. You can see a number of tributaries coming off to the east and west, and the triangles show those 3 major reservoirs, and you can also see where they've planned to put some dams and barriers, etc. And you can see the rivers and the canal network. Just by looking at that, you can see that water is being moved all over India and Pakistan as a result of water management of this Indus River and this Indus drainage basin. We've already covered lots of information about a new place and a new topic. It's always worthwhile stopping and just writing down what you can remember. So grab a piece of paper or a post-it note or a revision card and just pause the video now. Give yourself literally 60 seconds to 90 seconds to write down everything you can remember to see what's gone in. Good luck. Okay, so when I did this task, these are the things that I was able to recall. So I know that we're studying the Indus River. I know we're studying the IBIS, the Indus Basin Irrigation System. I remember that it travelled the length of Pakistan to the Arabian Sea from a north to south direction. I remember there was a water agreement, if I think about it, it was 1960, and it split access between Pakistan and India. I know that the Ibis system started as a series of canals, and that over time large dams were put in place, and hundreds of smaller dams were also put in place as well. And I know that canals are also used to transfer water. Here are a couple of pictures to show what's going on. So in the first picture on the left, you can see the size of the dam. And if you look closely, what you'll see is that there's a road on top of the dam, really. So transport can travel from one part to another across that reservoir. You can see the little street lights and everything. So it gives you an idea of scale. And then in the distance, that lake is the reservoir that has been created as a result of damming the river so that the water backs up behind. Now, in many countries, those sorts of reservoirs are also really important for fishing and therefore giving people a supply of protein, and also for hydroelectric power. In some countries like Egypt, where we've got Lake Nasser, what we also have is tourism. That's not so typical here, but it is a development that could be made, I suppose. In the right-hand side photograph, you have a young lad kneeling down on the farmland, and you can see the powder is almost sort of a white colour, and it talks about farmland being ruined by salinisation in Pakistan, and that's because the water that is standing in the reservoirs, etc., evaporates very quickly. You have fast evaporation, and what you're left with is salt, effectively, on the land. On a small scale, you've done that in science in the lower school, where you've had a crucible of water, and you leave it or you evaporate it with a Bunsen burner, and you're left with the salt around the edge. This is just exactly the same thing, but on a larger scale. And the salt is going to have a really negative impact on farming and the amount of crops you can produce. So here's a table talking about the advantages and the disadvantages of the Ibis system, the Indus Basin irrigation system. Pause the tape here and draw a table and write down the advantages and disadvantages. It says the following. The advantages are, we've got improved food security for Pakistan, 14 million hectares of land can now be irrigated. They've improved their yields of wheat, but also things such as fruit, so the diets have not only become greater with greater calorie intake, but more varied, which reduces malnutrition, because you can have all the calories in the world, but if the food isn't balanced, you're still going to have health issues. So this has helped address that. As I said before, with the reservoir, we've now got fish farming, which adds protein to diets, and we've got HEP, hydroelectric power, generated by those main dams, which as a subsidiary then helps improve the economy of the area. However, there are disadvantages, and those include some farmers are taking an unfair share of the water. So if you're further up the canal system, people are taking more water, leaving less water for those people nearer to the Arabian Sea. Water is lost through evapotranspiration, and that leads to salinisation, which causes long-term problems for the soil. Additionally, population is increasing in some of these countries, and as a result, it's putting increased pressure on the amount of farming that needs to take place. So there's more demand on greater yields, and it's expensive to maintain. So it costs money to maintain the dams and the reservoirs. It costs money to make sure the hydroelectric power systems are working, etc. So there's advantages and there are disadvantages. And it might be worth drawing that table out and then even shading them in to show social, environmental and economic impacts. This is a little maths challenge. We've been asked here to draw a pie chart to show land use in the Indus Valley using the data below. So you've got this information. Wheat accounts for 44%, sugarcane for 7%, animal food for 15%, rice for 15%, and cotton for 19%. So let's just look at those crops first of all. So wheat will be used by local people in their food supply, etc. A lot of their diet will rely on wheat. Some of it will be exported. Sugarcane is often referred to as a cash crop because it can be exported overseas, so money can be made from it. Animal food is important because it helps the livestock to thrive, and therefore people make more money out of selling their livestock or by eating the produce and therefore having a supply of protein in their diets. Rice, again, is a staple, and cotton, again, is a cash crop which can be exported. Cotton is a really thirsty crop though and relies on a lot of water, and so whilst the country might make a lot of money by growing cotton, it might not be environmentally the best choice and economically, I suppose, the best choice to use. So that data adds up to 100%. If I need to make it into a pie chart, I have to remember that 100% of a cake is the whole cake, and if I've got a whole cake, it's 360 degrees in that circle of that cake. And therefore I have to times my 100% by 3.6 to give me 360. So I simply take each of those percentages one at a time and I times it by 3.6. So I would do 44 times 3.6, that would give me the degrees. I would do 7 times 3.6, that will give me the degrees, and so on and so forth. My degrees should add up to 360 or near to. Your pie chart needs to be drawn now, so press pause and draw your pie charts and then check with the next slide to make sure that they look the same. Good luck. Okay, so here's the pie chart that I've drawn using Excel. Please take a look and hopefully yours looks the same. You can see that nearly half of the production is wheat and then 19% is cotton, etc. So you can see how they've been split out. Here's our 6th marker, and it says, use a named example to evaluate the effects of a large-scale irrigation system. So if we saw that question, we'd instantly say to ourselves, this is about the IBIS, the Indus Basin Irrigation System. This is in Pakistan. It also affects India. You've been asked to give a named example. You've been asked to evaluate the effects. So let's have a look at what the examiner is hoping for. So your named example, they're hoping that you'll remember IBIS, Pakistan, a series of canals and reservoirs. It's used to transfer water and allow irrigation of farmlands. It increases yields and the productivity of an area. So it's worth just jotting a few notes around. Evaluate means to consider the advantages and disadvantages. So here's the advantages from our table that we drew earlier, and then here are our disadvantages, and we're going to write about those in turn. Now, before I start any 6 or 9 mark case study type question, I'm always going to try to think about the key words and the key language that I'm going to include. Remember, we're writing as geographers. So the phrases economic, social, environmental, life expectancy, nutrition, development, HEP and sustainable are words and phrases that I'm going to try to shoehorn into my answer. Pause on this slide and try to write a 6 mark answer. A model answer may appear, but it's best if you try to do it yourself first of all. So using a named example, evaluate the effects of a large-scale irrigation system. This task should take you approximately 8 to 10 minutes. If you are struggling and you've moved on to the next slide, take a look at this guide to help you put things in order. So I'm going to write a little bit of an introduction. The IBIS, what is it? Where is it? Then I'm going to put the advantages, then the disadvantages, then a conclusion. This is very much like our structure strips that we've been using in class. So if you've struggled and you've moved on, pause again and see if you've put your response in this format. Okay, so hopefully by the time you're on this slide, you have written your own response and you're just reading mine to double check to make sure that we've got the same sorts of responses. Remember, I've also done mine in time conditions, so mine may or may not be better than yours. So if yours is better than mine, brilliant. If there are ideas in mine you haven't got, please feel free to take them and make them your own. So I've written the following. The Indus Basin Irrigation System, the IBIS, is an example of a large-scale irrigation system. I would only refer to it as IBIS from this point on. It runs the entire length of Pakistan, and the drainage basin includes Pakistan, parts of India, China and Afghanistan. Make sure you put capital letters for country names because the examiner would expect it or like to see it. The system is made up of a series of canals and reservoirs. There are 3 larger reservoirs and 100 small ones. This network allows irrigation of farmland. I haven't written too much about the system because the examiner is wanting me to evaluate it. So I've given them a brief bit of background information and now I'm going to think about and focus on the advantages and disadvantages. So, the advantages have included a sustainable food supply for the people of Pakistan. In addition, fish from the reservoirs add protein to the people's diets. Improved nutrition will have an impact on life expectancy and overall health. In addition, the reservoirs have allowed the development of HEP, hydroelectric power, which has enabled power to some communities near the large reservoirs, which allows industry to develop. If you are copying my response, try to highlight the key words so you see the geography that I am including. I've gone on to say there are negatives which include disparity between the amount of water each farmer gets. This can lead to social inequality and deprivation in certain areas. Some areas are affected by the rates of evaporation, and it can lead to the salinisation of the soil, which has a negative impact on the productivity of the land. As population increases, water demand will increase, and the system requires investment in order to be maintained. In conclusion, the advantages outweigh the disadvantages. However, it's important that communities work together to make sure the system is fair and that environmental impacts are overcome. This is the end of the lesson on the IBIS system. My name is Mrs. Wingham, and you've been listening to Geography Rocks.